Howdy folks, today we're going to be going over the first step in XFLR5, which is creating the airplane actually. And so the first step in doing this is you're obviously going to want to open up your XFLR5 window. I have mine open here, I'm just going to full screen that. And it's going to show up as a blank black screen, as you can see. So the first thing that you want to do is you want to bring in your airfoil profiles, because you're going to be using the airfoil profiles that you have a lot during this aspect of XFLR5, because when creating your plane, obviously you want to make sure that your wings and all of your surfaces match the profiles that you want them to match. So what you're going to want to do first is go to File, Direct Foil Design, and it's going to bring up this, which is just the spline foil, which automatically gets inserted into XFLR5. So then you want to click this guy, open, and you can see mine brings me automatically to my ultralight folder. You obviously might have to navigate depending on how often you use XFLR5, and then you're just going to double click on whatever downloaded datasheet you have. So I have the Clark Y aerofoil, and it'll show up there. I want to bring in my second aerofoil, which is my flat plate aerofoil. And so now they're both showing up here. And now I'm going to be able to use these in the future in my XFLR5 analysis and design. So the next step in this process is going to be actually creating your plane. So you want to go to File, Wing and Plane Design. And it's going to bring you here, which is just a blank 3D modeling screen. And from here, you can start building your plane. So go to Plane, define a new plane. And it's going to bring you to the plane editor. You're going to spend a lot of your time here, obviously, because you're going to be making changes to the airplane design as you get more data coming in. And so that's what you're going to be doing here, is you're going to be editing your airplane. I'm going to name my airplane Test Sim 2. You can name yours whatever you want. Our actual airplane is named Tyler Durbin, I think, at Flight Club Aerospace. So I'm going to take you through the steps here of designing an airplane using a design very similar to the one we're using at Flight Club, although it's not going to be exactly the same, just for simplicity's sake. But you can follow along and you'll see how you can input data into XFLR5 and how that shows up as the airplane. So the first thing that you want to do is you want to define your main wing. And when you click define, it's going to open up this window here. And you can see it already generates this wing profile, or not profile, this wing design here. It's actually just flat because it doesn't have any airfoil. But we're going to change all of this. You're going to want to make sure that your units are correct. We do our units in inches, just because. And so what each of these rows is going to be is each row is, I guess you could say, a cross-section of the wing. And so when I click on number 1, you can see it highlights this cross-section in the middle. And that's what this Y offset 0, 0, or 0 is going to be 0 on the y-axis, and then we highlight the second profile, and it's going to highlight the two tips and that's offsetted 39 inches out from 0. And you can create as many or as few cross sections as you want. Because our airplane is a rectangular wing and doesn't change a lot throughout the span, we only need 2. We only need the center, the roots of the wing and the tips of the wing, and whatever generates in between that is accurate to what we're designing. So for our first cross section, it's going to be 0. The chord of our first cross section is 72 inches. And it's going to be the same thing for our last cross section as well. And that's because we have a 6-foot chord, which we discovered through our own calculations. And I would recommend that before you do anything with XFLR5, you've run preliminary sizing calculations for your own airplane. So yeah, so we can put a 72-inch or 6-foot chord for our first cross section. This is the offset in the x direction. and there is no offset in our x direction. Our chord is going to start at the same place as our next cross section is going to start. So we have 0 offset there. We have a 3-degree dihedral, so we're adding that in. Twist, we don't have any twist. Okay, now this is the interesting part. So this is where you select the actual the profile, the airfoil profile that you're going to be using. So you just click here and you click the drop down. So we're using a Clark Y aerofoil for our main wing. So we want to make sure that our main wing has that profile. As you can see, it looks a bit weird right now, and that's just because we haven't defined any of the tip things. So you'll see that it actually tapers off to whatever this row is defined as, which doesn't have a foil, so it goes to flat. So XFLR5 is really good at generating whatever's happening in between. But we don't want this weird looking wing. We want our own rectangular wing. So now we're going to input the offset here. So this is going to be half of your wingspan, whatever that is. And for us, that's going to be 186 inches out from the root. Chord is going to stay at 72 because we have a consistent 6-foot chord. There's no taper in our wing. You can actually see these sort of data points of your wing on the right side here. So with 72 and 72, we have a taper ratio of 1, which means our wing doesn't taper, it's rectangular. There is going to be no offset because we don't want our wing to have any sweep, and you can see it just changed that root to tip sweep right there. There's not going to be any dihedral at the tip, only at the root, and we're going to stick with the Clark Y aerofoil there, which is going to make that a consistent Clark Y rectangular wing of the dimensions that we inputted. Once you're done with that, you're going to want to save it, and now we can move on. Or actually, before we move on to the elevator, I want to talk about where you put your wing. So this data entry here is interesting. So I'm just going to talk about the X and Z data points, and we'll get to the tilt angle later. This is essentially just where your wing goes in the space of your 3D modeling. 0, 0 is going to put the leading edge, so whatever points you put in here, that's where it's going to put the leading edge center of your wing. For me, I like to have the 0, 0 of my 3D modeling space at the center of lift of the wing. So I'm going to actually move my my wing so that the quarter chord is at the origin of the 3D modeling space. So now we can move on to the elevator. And it's going to be the same exact process. Usually, at least for us and Flight Club Aerospace, our actual elevator is a lot more complicated than our wing. It's just weirdly shaped. It's not rectangular, so we have about 5 rows. But for the purposes of simplicity here, I'm just going to go through 2 rows, and it's the same process as the wing, except with different data entries, obviously. Move on to the fin. The fin is going to be the same process, except instead of instead of it symmetrically going out in the offset, it only goes out by 1. So XFLR5 automatically does that for you, which is really nice. So now we can start working on that. And although it does say that it's going out in the Y direction here, once you actually input that into your 3D modeling space, it's going to extend in the Z direction as a vertically oriented vertical stabilizer. This is the only of our control surfaces that we're doing today that doesn't actually have a 1-to-1 taper ratio, and you can see that here, that the tip of our fin is a little bit shorter than the root of our fin. And we're going to offset that. Foil, once again, we're using flat plate for the fin, and we can save and move on from there. Now we're going to input the positions of the elevator and the fin. And the positions of the elevator and the fin are once again decided by preliminary sizing calculations, mostly regarding this data point here, which is the tail volume coefficient. So you can do those calculations on your own. I would recommend finding a textbook or somebody to help you do that. I bet we have information about the tail volume coefficient on our blog as well. And we want our fin and our elevator to be at the same position, so we're doing that. So something interesting here is with the elevator or with, I guess, the data points being entered in here, is that it doesn't really matter what they are as long as they are what you want them to be in relation to each other. So the actual origin of the 3D modeling space doesn't matter. It's just a preference aspect. And so when I'm thinking about the x position of this, I'm thinking about that x position in relation to the main wing position, not just in relation to the 0, 0. That's just an important note. I'm assuming if you've done any 3D modeling beforehand, you're probably familiar with that. So now we can talk about the plane inertia. This is just where all of the different mass points are going to be, how we give mass to our airplane. Once you click that, it's going to open up this window here, and we can start with the main wing. XFLR5 is nice in that it calculates the center of gravity of your surfaces beforehand. You can see that down here. And we can just add in our wing mass, which is projected to be 80 pounds. Again, that's from preliminary calculations. XFLR5 won't do that for you. You can now save it. Our elevator is going to be around 5 pounds. Our fin is going to be around 2.25 pounds. Cool. So as you can see, that just relates to 87.25 pound total mass, which obviously isn't going to be how the plane is actually flying, because we have our whole fuselage assembly, our batteries, or in some cases fuel, our pilot, etc., etc. So to compensate for all of that, we're going to add in a singular point mass at where we where we calculated the center of gravity of all of those things minus our surfaces to be. And so the leftover mass is going to be 415.864 to give us a 503.114 pound total mass. 32 and negative 27.420. So something to note about the center of gravity here is center of gravity has a lot of influence on the performance of your aircraft. So when designing your plane, I would recommend not basing things off of your center of gravity, but also basing your center of gravity off of the other things in your airplane. So make sure that you have the capability to move your center of gravity around for optimal performance. The center of gravity that I put in here has been, we've tested our airplane using this simulation, and we tested it and used that data to optimize our center of gravity. So now we can save this, and bada bing, bada boom. There we have it. Our airplane's there. So that's all for today. Next time, I'm going to be showing how you can analyze the results of your airplane, how you can run simulations on your aircraft and analyze those results. But that's all for today. Thank you guys for tuning in. I'll see you next time.